Hi, in this video we're going to consider the problem of a line of black circles, which I'm just drawn two here, and we're placing a red circle so that it just doesn't protrude beyond the top edge of the black line. And to solve this problem, we're going to need a triangle. So if you haven't had a chance to start solving the problem, why don't you pause the video and try to find a right triangle that you think is going to help us solve the problem. Okay, so the right triangle that I picked was this one. First, we'll have one side will be the horizontal line from here to here, which, since this is of length 1, is of length 1. And then we have the point that the little red circle and the big black circle come to each other tangentially. Let me show you what I mean. I'm going to draw a black line here, and both the big black circle on the left and the little red circle are tangential to that diagonal black line. And since the radial line is perpendicular to that, that tells us that the line here, I'm going to draw both the two radial lines here. This is the radius from the big circle to here, and then we keep on going to the center of the little circle, and since they are both perpendicular to the black tangential line, they are in a straight line. So I've drawn a straight line there. And so then as the final side, I'm going to draw the final part of our right triangle here, and that then is the right triangle I've used to solve this problem. If you haven't solved it yet, please pause the video and see how we can use this right triangle to find the length of the little circle, red circle, if the big circles are of radius 1. Okay, so we want to find the radius of the little circle. So here I'm going to call it R. And we know that the length of this diagonal line, the hypotenuse, the blue hypotenuse, has got to be 1 plus R. And this opposite edge here is R less than 1. This has to be 1 minus R. Since when we add these 1 minus R plus the 1 R together, we get 1, which is this distance. So we now have our three sides of our right triangle. The two legs are 1 squared, we're using the Pythagorean theorem, plus 1 minus R squared, and that has to equal 1 plus R squared. And that gets us 1 plus 1 minus 2R plus R squared. We expanded the expression on the left is equal to 1 plus 2R plus R squared over here. And we can cancel out a bunch of terms. There's an R squared on both sides, which cancels. And there's a 1 on both sides that cancels. And we end up, if we bring this, we're going to bring this 2R term over to this side. We end up with 1 is equal to 4R, and that makes R equal to 1/4. So the little red circle has exactly 1/4 the radius of the big circle. And this shows the power of using right triangles to solve problems with circles. And we have other problems that we'll consider like this one in the lab.